course, let us discuss another aspect of random variable, that is expectation of random variable. So expectation of random variable takes values with respective probabilities. So generally probabilities are important or needed for study of expectation of random variable. So the values depend on chance. The variable is random or stochastic. So sometimes it is called random, and sometimes in some books we'll find it is called stochastic variable. The univariate probability distribution depends on the set of values together with probabilities. The variable takes finite or innumerably infinite values, and it follows a discrete probability distribution. So it will be clear when we will discuss an example. If x is a variable, xi's are values with respective probability pi. So x is a variable, x1, x2, so on up to xn. They are values of the variable. So I ranges from 1 to so on up to n. And the probability p is equal to p1 respective. With x1, probability is p1. With x2 values, probability is p2. So on. For xn values, probability is pn. So pi is equal to p1, p2, so on up to pn. Now if phi x is a function of the variable x, it takes the values phi xi and pi be probability. Now expected value of the function, then if phi x is the function of the variable x and phi xi's are values and pi be probabilities. So for a function it is phi capital X and respective values capital X and respective values phi xi, these are the values, and pi be probability. Then expected value of the function, expected phi x is equal to sum pi and phi xi, small xi, where sum pi is equal to 1, that means sum of probabilities, total probability is 1. So this I ranges from 1 to n. So when a die is tossed, let x be the number of it appears as 1, 2, 3, 4, 5 and 6. Either 1 may appear or 2 may appear and so on, or 6 may appear. And expected x is equal to sum xi pi. I will range from 1 to 6. 1 to 6. So this will be equal to 1 into 1 by 6 plus 2 into 1 by 6 and so on, plus 6 into 1 by 6. So this will be, when you will simplify, it will be equal to 7 by 2. Now another example, what is the expectation of the number of failures preceding the first success in an infinite series of independent trials with constant probability p of success in a trial? So we have to find out the expectation of the number of failures. So first success, after that it failed several times. Let x denotes the number of failures preceding the first success. Then x takes the values 0, 1, 2, so on, because the trials are infinite. So with probabilities, given P is the probability of success and Q is the probability of failure. So it is P, next is QP, next is Q square P, Q cube P, and so on, when Q is equal to 1 minus P, and P plus 1, success plus failure, is equal to 1. So I have given the hints here. Expected X is equal to 0 into P. So first was 0, so 0 into P plus 1 into QP plus 2 into Q square P, and so on. So after simplification, we'll get, it will be Q by P. Q by P means 1 by P minus 1. So in this case, expected X will be 1 by P minus 1. Now theorem 1. The expectation of the sum of two stochastic variates is equal to the sum of their expectations. The sum of two variates. So expectation of the sum of two variates, expectation x1 plus x2. Okay. So this is equal to double sum, one for x1 and one for x2. So double sum xi plus xj. You see, here it is capital, here it is small x. These are values into function xi and xj. So if we multiply double sum xi, f xi xj, first we have multiplied by xi plus multiplied by xj, double sum xj. Yes. So this is nothing but expected x1, this is nothing but expected x1, and this is nothing but expected x2. So therefore, expected x1 plus x2, that means expectation of sum of two stochastic variates, is equal to the sum of their expectations. This is the sum of the expectations. Okay. Now theorem 2, the expectation of the product of two independent stochastic variates is equal to the product of their expectations. Okay. That means expected xy is equal to expected ax into expected y. Let the stochastic variate x assumes m values. That means x1, x2, so on up to xm. And that of y takes the n values, y1, y2, so on up to yn. Let the probability of x, assuming the value xi, be pi. So probability associated with xi is pi. So I ranges from 1 to m, and that of yi is p prime. Okay, p prime. As per compound probability of independent variables, so we'll have to apply the method of compound probability. The probability that x assumes the value xi, and at the same time y assumes the value yi, is pi pj prime. So according to compound probability, it is pi pj prime. So this is equal to pi xi into some pj prime yj. Okay, yj. So this is equal to pi xi into expected y is equal to expected y, if we write y first, some pi xi is equal to expected x into expected y. Expected x into expected y. So expected xy ultimately is equal to expected x and expected y. So thank you very much for watching, and keep on watching. Please share. Thank you.